Okay, going back to topic 13C. I'd started and got interrupted by a fire alarm. So I was saying we're doing the fifth root. That means we're looking for groups of 5. I like to do my factor trees as prime factor trees. There's different ways to do factor trees. You don't have to do it like mine, but I like to get it down to prime numbers. So I always start by saying if the number's even, I know I can divide by 2. So 96 is even. I can divide by 2. 2 times 48. 48's even. 2 times 24. 24 is even. That's 2 times 12. 12 is even. That's 2 times 6. 6 is even. That's 2 times 3. And now I'm down to all prime numbers. That's what I say when I get down to a prime factor tree. Again, I'm looking for groups of 5. 1, 2, 3, 4, 5. I have 5 2s here. So they can come out. I don't have 5 3s, so that has to stay inside. And make sure you write that 5 there. Because if you don't write the 5, you're saying it's the square root of 3. And it's not the square root of 3, it's the 5th root of 3. So that is my simplified answer. And remember, when it's asking for you to simplify it, we're not looking for it in a decimal form. So don't put this in your calculator and get it as a decimal form. You can put it in, check it in your calculator, but we're looking for this kind of an answer, not decimals. All right, let's try this one. This is the third root, so I'm looking for groups of 3 because this is a 3 out here. So 125 is not even. When I can't divide something by 2, the next number I always check is 3, but I also can't divide 125 by 3. Can't divide it by 4. I can divide it by 5 though. So 125 divided by 5 is 25. Same thing with 25. I can divide that by 5. And you can see that I have a group of 3 5s. So that's a perfect cube. 125 is a perfect cube. There's nothing left over. In terms of doing my letters, I can rewrite a to the 12th and expand it as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. B to the 4th is 1, 2, 3, 4 B's. And C to the 3rd is 1, 2, 3 C's. So I'm looking for groups of 3 for my letters as well. I have one group of 3 C's. I have 1, 2, 3, 4 groups of A's, and one group of B's with 1 left over. So here's what's coming out. I have a 5 coming out because I have a group of 3 5s. I have 1, 2, 3, 4 A's coming out because I have 4 groups of A's. I have 1 B coming out because I have one group of 3 B's, and I have 1 C coming out. And the only thing I have left inside is that leftover B. And again, make sure you write that 3 or else you're saying it's square root, and it's not square root, it's cube root. All right, on this one, evaluate the 4th root of 80 minus 7 times the 4th root of 5. So when you're adding and subtracting, you've got to have like terms. And right now, to have like terms when you're doing this, you need to have the same root. So you need to have this be the same, and it is. I've got 4 and 4, so that's good. But you've also got to have the same thing here, and right now you don't. You have an 80 and a 5. So you almost treat what's under the radical sign as like an x or a y. So right now, like this is like an x and this is like a y, and they're not like terms, and you can't combine them. But we can try to simplify. So if I take 80 and I do a factor